In this video, we're going to learn how to find a missing side length when we're given two similar triangles. So some reminders about similar triangles and how do we know if triangles are similar? We know two triangles are similar if the two triangles have corresponding angles congruent and sides proportional. Okay, so corresponding angles congruent, I wrote the wrong word here, and corresponding sides proportional. Okay, so if two triangles are similar, we can use the fact that the sides are proportional to solve for missing side lengths. We discussed in the first day of learning about similar triangles that proportional is when two sides have the same ratio. So that's when we went through and we divided, the biggest sides on each triangle, the smallest sides on each triangle to see if we got that same ratio every time to show they were proportional. Well, since they're proportional, we can set up a proportion to find a missing side length in two similar triangles. So a proportion is two ratios or two fractions that are set equal to each other. Now, the way that we're going to fill it out in this video and that we do in class is I like to always put the bigger triangle's information on top and the smaller triangle's information on the bottom for every single proportion that I write. And it's also important to know that the bigger triangle on top and the smaller triangle on the bottom, those have to be corresponding sides. I can't just pick any sides that I want. They have to be corresponding sides that go with each other. And the same over here. The bigger triangle on top, smaller on the bottom, but they have to be the corresponding sides. And I'll show you how to use similarity statements to get those corresponding sides. So let's do a few examples. So the directions say, given the two triangles are similar, find the missing side length. Okay, so we don't have to say if they're similar. We don't have to give a theorem. I'm telling you they're similar. We need to use that fact to find the missing side length. So I always start off by just setting up a blank proportion that I'll fill in as I look at the problem. So where you start is not important. It doesn't matter. I put the bigger triangle on top. So I look at my bigger triangle here, and I just pick one of the sides that I wanted to start with. In this case, I'm going to start with 24. Okay, so 24 is bigger triangle, so I put that number on top. So I need to put the corresponding side from the smaller triangle on the bottom. So the way I can tell is by looking at this similarity statement. So 24 is side KL or LK, which is the first two letters written in that statement. Triangle LKJ, LK is the first two letters. So I go to the second triangle in that statement and see, well, what are the first two letters here? LC. So I go to side LC in the smaller triangle and see that there's a 12 there. So I put 12 on the bottom because 12 is the corresponding side in the small triangle that corresponds with 24. Over here, again, bigger triangle information on top. Well, the only other side length I have for the bigger triangle is 16. So I know that goes on top because it's in the bigger triangle. 16 is side JL or LJ. That's the first and last letters of that similarity statement. So I go to this part of the similarity statement, and the first and last letters are L and D. Well, L and D, that side is missing. You'll notice there's a question mark. I'm going to put an X to show that's what's missing, and that's what I need to find. So once you have your proportion set up, bigger on triangle on top, smaller on the bottom, you made sure they were corresponding sides by using the similarity statement. Now we can solve this proportion by cross multiplying. So I'll do 24 times X, which is 24X, and 12 times 16, which is 192. So it equals 192. So I just multiplied across. Now we have a one-step equation to solve. 24 times x, so the inverse of that is dividing by 24 on each side. And we get a final answer of x is equal to 8. So that missing side length there would be 8. Let's do another example. So again, I start off with a blank proportion that we're going to fill in as we go. So where you start on the bigger triangle does not matter. So I have the choice to start with the missing side or with 20. I'm going to start with 20. So 20 is the first side I'm looking at, and it's on the bigger triangle, so I'm putting it on top. 20 is side GE. Well, GE, that's the first and last letter in that similarity statement for that first triangle. So I have to go to the next triangle in that statement and see what the first and last letters are there, G and S. So if I try to find side GS, the number that's on that side is 10. So I'd put 10 on the bottom because those are corresponding sides. Bigger triangle over smaller triangle and the corresponding sides. For the other part of the proportion, bigger triangle, the other side is the missing side. Question mark, so I'm going to put an X. That side GF. Well, GF is the first two letters in that statement. So I go to the first two letters for this triangle, GR, and there's an 8 there. So 8 is the corresponding side for that triangle. So now that we have our proportion set up, we can cross multiply and solve. So 10 times x is 10x. 20 times 8 is 160. To get x by itself, I would divide both sides by 10 to get x is equal to 16. So you have to set up your proportion, making sure to keep the bigger triangle on top, smaller on the bottom, and make sure you're matching up the corresponding side lengths. So let's do a couple more. I want to do this one with us. So here, again, I'm going to start off with a blank proportion. Now here, you'll notice I don't give you a similarity statement. And the reason I don't give you a similarity statement is because we have a smaller triangle. So triangle LSM or LMS, this small triangle, it's inside of this larger triangle here. So there's still two triangles, smaller and larger, but they're right inside of each other. So the corresponding sides are going to line up. So 66 for the big triangle from T to S will correspond with LS. Okay, they're both on this diagonal for the triangles. 54 for the big triangle on the bottom will correspond with 45, the bottom of the small triangle. So I'm going to start with 66, so big triangle information on top. So I'm going to put 66 on top. And the corresponding side in the smaller triangle is missing. So I'm going to put an X. Big triangle on top. So the bigger triangle is 54. It's on the bottom of the big triangle. So the number on the bottom of the small triangle is 45. So that's the corresponding side. So once that's set up, we can cross multiply. So I'd get 54x, and then 66 times 45 is 2,970. And then if you divide both sides by 54, you end up with x is equal to 55. So for all of these, you have to set up a proportion, bigger number on top, smaller number on the bottom, and make sure they're corresponding sides, okay? Once you have it set up, we cross multiply and get the variable by itself.